Hello, everyone. Welcome to this session on mapping your business model to API design. My name is James Moschou, and I'm the founder of Criteria, which is a collaborative API design and governance platform. So I come from both a product and an engineering background. My passion is really bringing people from those two functions together to work a lot more collaboratively. First, I'd like to start the session with a personal story of mine from early on in my career. I was a product owner working at a prop tech startup. So our startup created an iPad app which allowed property managers to inspect their units and apartment buildings. So this replaced the pen and paper process with data, and it synced up to the cloud, and property managers could get analytics and insights over their entire portfolio. And part of our platform's value was the ability to integrate with existing leasing systems of records that these property management companies used. So I'll show you what that sync workflow looks like. First, our system would pull down the list of properties and units from the leasing system of record. Then a property manager would walk the building, conduct inspections, and sync that data back up into the cloud. Our system would generate inspection reports, and we'll use an API to attach those as documents back against the lease record in the leasing system of record. And then if any maintenance work needed to be scheduled, we'd also create a work order record and sync that against the maintenance system, again, using an API. And so the thing about this industry, real estate property management, is that a lot of these systems that people used were what we might call legacy, in quotes, right? They had really undiscoverable APIs, poorly documented, soap over XML, kind of that old school mentality when it came to APIs and developer experience. And then there was this new kid on the block, this new tech startup also in prop tech. And when we heard about them, they were modern SaaS. They also had a modern API. And our head of revenue, who was not technical in the slightest, was really excited to integrate with them, because even he knew that a company with a great API would be really easy to integrate with. And so this would be a quick win for the company. We could unlock new possibilities, get new customers, and it wouldn't take too long in terms of our roadmap and development. So the time came for us to do a deep dive planning into what this integration might look like. And when we digged deeper into the send work order workflow, we realized there was actually a mandatory field in the request that we needed to pass called a category ID. So a work order category ID. And so none of the other systems had this field. So the question was, where does this come from? Well, apparently there was another endpoint that we needed to call called get work order pick lists. And the idea here is that we would call this endpoint that would return back a list of IDs, opaque IDs, and a list of opaque names as well. And then the idea is we would present this to the end user, and the end user would then make a selection from a drop-down menu, say, and then we could feed this back into the send work order API. And the problem with this is that we weren't building a user interface. We were building a background sync that happens once the property manager came back and plugged their iPad in, kind of a set and forget kind of thing. So this API really didn't fit our use case and what we were trying to do with it. So then my role as a product owner is to come back to the company and say, hey, we've got this setback. It's not going to be as easy to integrate as we initially thought. And our head of revenue really couldn't wrap his head around this, because all he heard was they had a great API, good developer experience. What do you mean you can't integrate when we could easily integrate against all these other bad APIs? So the takeaway here is that whether an API is good or not, or whether the design of an API is good or not, needs to consider both product, business, and technology. It's not just whether you follow best practices or you have great documentation or an accessible developer portal. You also need to map the use case and the business model and what people are trying to do with it. So with that and the rest of this session, I'd like to take you on a journey on developing a fictional order fulfillment API. So if you think about order fulfillment, say you place an order with a warehouse, that order needs to get picked and packed and then sent to a recipient. So we're going to be offering this as a service, and of course, delivering the service through an API. Here are our product requirements. Pretty simple and pretty high level. Hopefully your product manager is going to flesh this out a bit more in the real world, but for now, it's pretty simple. Let's place an order and then track an order. And then in order to place an order, we need to know what we're ordering, who it's going to, and how it's getting there. So say these are our high-level requirements. We've given them to our tech lead. And our tech lead has heard of this new thing called REST. By the way, this talk is not going to be about REST versus gRPC versus GraphQL. I'm just using this as an example. But say that for the first iteration of how we're going to implement this API, we're going to follow REST best practices. So what might that look like? Well, in REST, we design around resources and then model actions on those resources. So let's figure out what those resources might be. First, we'll have an order resource. And then an order is going to be made up of one or more products. And so we'll model a product as a product resource. And then we also know we want to send it to someone. So let's have a recipient resource in there. And this lets us send more than different orders to the same recipient. Then, of course, we need a shipping provider. So this is going to be the postal service or the courier service who's actually going to send the goods to the recipient. And then, if we send the order, it's going to be packaged up as a shipment. There may be more than one shipment, depending on our warehouse timing. And each shipment will have a label, which will contain the tracking information, and also inventory items, which represent the actual physical goods sold and transported. So here we have a RESTful API. We can go further and define the endpoints and the methods and the payloads. I won't go into that detail here, but for now, we've got small, narrowly scoped resources. They're modular, they're composable, and we can compose them together into different use cases. And so, of course, we give this to the customer, and what do they say? They say, I just want to call one endpoint. If you've worked in customer-facing APIs, especially with enterprise clients, this probably is not unfamiliar feedback. I've heard it many times in my career. And you know what? They're not really wrong. If you think about what you need to do to create an order, that one requirement we had originally, first you need to create or fetch the product resources, then you need to fetch the provider resource. You also need to create a recipient resource, but if you've already created them, then you need to store the recipient ID somewhere. So maybe you need to implement some sort of storage logic on your end, or we need to implement a search recipients endpoint as well. And then once you create the order resource, you need to retrieve from the order response the shipment resources and then query them in order to get the tracking information. It's really a lot of steps to fulfill that one use case that we originally had. And so what's going on here is that API design is always a negotiation between the provider and the client. Both parties need to do work to deliver that customer value. And the question is who does what and how much work does each party need to do? It's going to be different for every situation you find yourself in and every kind of business model or requirements that you have. So a lot of the time, APIs will provide the bulk of the business logic, and you'll see that the client is expected to provide the end user experience, as well as some glue logic, we can say, to stitch those endpoints together to fulfill a particular use case. But if we know exactly what end user experience we're trying to build, we can move the API closer to that experience and make it a lot easier for the customer to use and integrate into their application. So this is where every screen or every button click, say, corresponds one-to-one with an endpoint that's made for that end user situation. So while this does make it a lot easier to integrate with, it also narrows the amount of clients that can or may want to integrate with you. And if we go back to our property management example from my career, this is pretty much what happened. That leasing system, that new modern SaaS, probably wanted to have an API strategy, and they realized they already had an API powering their web app. And so they just opened it up, documented it, and called it a day. Which is fine if you're selling to clients who want to create their own web interfaces on top of your data. But from a business point of view, that may not be the most effective use of an API strategy. And certainly for us, it wasn't really usable or desirable for us to do that. On the other end of the spectrum, we have data APIs. This comes from the mindset where an API's role is just to expose data over the internet. And you typically see these kinds of APIs correspond to database layouts, so an endpoint per database table. These also don't really provide much value to clients and customers because they have to do all of the work to implement the business logic. So the right kind of position in this negotiation is going to be somewhere in the middle. Not the same for everyone, but certainly not on the two ends. So let's go back to our order fulfillment API and kind of redesign it for the kinds of clients that we have. So if we streamline the create order workflow into one endpoint, it might look something like this, where we're specifying the SKUs, so those are the products, the recipient address, and a shipping method, all in one request body payload. Goes to our API, and we return back with the tracking information. And if you look at what's happening in this workflow, it really does resemble a purchase order form that a company might have internally as a kind of a manual process. And so in this business model, we're really automating this purchase order form workflow with our API. And let's say that this is the kinds of enterprise company that we have had commercial success with. Companies looking to automate their internal logistics and operations practices. So if you think about these kinds of companies doing process automation, the teams or departments looking at us as a solution are more cost centers. They come from operations and logistics departments. They probably don't have dedicated IT. And when they're evaluating a solution, they're coming at it from a project over product mindset. So for them, they're really looking to minimize the scope of that potential project. And they're not really caring about how much the API can adapt and evolve over time. So in this kind of situation or enterprise clients, they're really looking for something that's quick and easy to implement within a fixed budget, more than something that's going to fit in a product architecture. So say we've had success selling to these kinds of enterprises who are looking to automate purchase orders. And then we get to a board meeting and the question comes up, how do we grow our revenue? How do we increase this company's revenue by 10 times? So let's go back to our business model and look at it through the lens of the customer lifecycle. So a customer might be aware of a problem, they might be considering solutions, and then once they've picked a solution, they'll go into purchase mode, sign the contract, implement it, and then they'll be hopefully in an expansion phase with the solution. So we're selling purchase order automation with our order fulfillment API. And the question they have is, does it support my use case? So the thing about process automation is that the process that you're automating already exists, and that often imposes constraints on the solution. So what's happening with us is we have to tailor this all-in-one endpoint to each new customer that we bring on board. They might have slightly different requirements. And we're doing that really to make it as easy as possible for each client to integrate, but the burden falls back on us to manage and support all these different permutations. In this hypothetical scenario, we might be charging a license fee. It might be seat-based, but the idea here is that it's a kind of a fixed non-variable revenue stream. And if we want to grow it, we have to grow the number of customers that we're selling to. And there's not much room for upsell or cross-sell or expansion in this solution that we've provided. And so this is what we're really looking to change. And the ideal here is that we want to find rapidly growing customers and then piggyback off that growth. So if we implement transaction pricing, this is per API, more API calls, the more money we make, then this is really ideal for us. We have to find rapidly growing customers who are going to grow, and with that growth, make more API calls to our server, and then we can make more revenue from the same set of customers. And so the target market that we've identified hypothetically is e-commerce retailers who are scaling globally. So maybe they were a retailer shipping in Australia, and then they're looking to expand into North America, US and Canada. That market's 10 times bigger than Australia, and so we would expect to see 10 times as much growth in revenue from this outcome. So the question these people have is not so much, does it support my use case, but does it scale globally? Can I use this one API and then reach the whole globe without having to reintegrate with multiple providers and multiple API solutions? And so for us, as we make this an optimization in our API design, what we want to optimize for is having that single integration that can scale internationally without requiring the customer to update their API every time they want to enter a new geography or a new market. So with this trade-off in mind, we can go back to our API design, that all-in-one endpoint, and see how can we change it and improve it to support this question of, does it scale globally? So the key here is that the bottleneck is in this shipping method field here in the request. So we've modeled it as a enum value for this all-in-one endpoint. And this is fine if your requirements are static, but if you're growing, every time we enter a new market or a new country, we have to go back and onboard new shipping providers and then integrate them into this enum payload. So that's a lot of work on us as a provider to update this enum, update the documentation, test it, test all the permutations. And then also for the clients, they have to go back and update their code every time they want to handle a new provider. So maybe we started out with Ozpost and Ozpost Expedite. Then we might add USPS, Toll, FedEx, so on and so on. That's every time we add a new enum, not only is it more work for both the provider and clients, but it's also breaking change that we have to handle and migrate. So what we can do is we can extract this out and parameterize the shipping method. So we'll create a new provider resource and then link that from the order resource. So now, instead of having a fixed list of enums, we can have a dynamic collection that's queryable. And this means that we only have to integrate once in order to retrieve all possible providers, perhaps filtered by country or region, and then use that to place an order. So now this means the API is much more scalable across all geographies. We can update which geographies and markets are supported over time without changing the surface area of the API and without introducing a breaking change. And so this is really going to help these e-commerce retailers who are looking to scale globally. It does come at the expense of time and effort for that initial upfront integration. There are more endpoints, there's more things to learn, there's more things to stitch together. Definitely is a worse experience for that initial integration, but the payoff is that it will scale over time. And so these are the kinds of trade-offs that we need to make when we design APIs. And it really comes down to what the customer needs and what your business model is. So here we are kind of reverting back to that modular design we had in iteration 1 that was very restful. But the reason is not because modular APIs are inherently better. The reason is because in this business model, we're willing to have fewer customers if those customers are going to grow much more rapidly, and we can implement transaction pricing on that growth. So there's many different kinds of trade-offs that we can make as we're going through this process of designing an API. So for example, we just traded integration time and effort in order to improve the agility of us and the scalability of our clients. Maybe you're targeting zero-touch developers who don't want to talk to anyone and won't expect to need support from a person versus a high-touch enterprise client who expects to have their hand held throughout the whole process. I won't go through all of these in this talk, but it's something to work out with your team, which requires both product representatives from product, business, and technology in the same room. So really, the point is you want to make as many iterations as possible and have as many conversations as possible. There is a right and wrong time to make design decisions. And the wrong time is in production after you've already shipped it. You will see in the industry, whether it's design, security, quality, everything is shifting left, and design is really no exception. And in fact, this is a solved problem when it comes to web and mobile UI design. We know that design starts off as a sketch and might progress to a wireframe. And then from that wireframe, we might have a pixel perfect mockup, and then maybe even a clickable prototype. This is normal and expected. And we do this to avoid having discussions about the color of the button, say, when you want to decide what information should be presented on the screen or what the purpose of the screen is even for. And if we take this as an analogy and apply it to APIs, we also have a similar process with APIs. We call it API first or API design first, which is where you design the interface of an API before you start coding it. And typically this looks like an open API definition or something similar. So I will make the argument actually that an open API definition is a hi-fi mockup of an API. It's that pixel perfect version of it. It's too high level to avoid, it's too low level, sorry, to avoid having that discussion over the color of the button. You'll have discussions over whether something should be named singularly or plural, if something should be in the request header, parameter, or body. Those questions are good, but there's a time and place, and they're not really getting to the business model or the product requirements of your API. So if we look at the lo-fi and hi-fi stages, there's really a lack of tooling there, and that's where criteria comes in to fill that gap. So criteria fills that gap for teams who want to build customer-centric APIs in a collaborative manner, much like how Figma brings our product and design and engineering together. It does the same for APIs. So we can switch to a quick demo. So here I've got criteria diagrams. This is a free tool to use, no sign up required. And when we think about the wireframing of an API, often people think in terms of use cases and examples. So here I can quickly model a quick use case. Maybe it will be that create order use case. And then we had to query the list of providers before. Right, so now we can see a kind of a sequence diagram of how we might use an API, and this can be exported and shared with your stakeholders and customers It's a very quick and easy way to visualize what an API is doing without getting into the details of how these parameters are communicated or what the request and response payloads need to look like, which are more technical discussions. If we come back to the actual criteria app as well, we can see what that looks like at a finer level. So if I create a provider's resource, you'll notice that the default use cases or operations are, create and update. We're not talking about whether something is a post or a put or a patch here. So keeping the language business friendly helps us think about why we're building the endpoint and not how it should be represented in the API. So I've created that resource and it's scaffolded all of the endpoints that I need without me having to think about it. This can be shared with your customers. So you can share this as easily as sharing a Google link and they can leave comments. And then from there, you can iterate on the API design without needing to get bogged down into the details as well. When you are ready, though, to start developing, you can export that open API definition, but think of this more as the output of an API rather than the medium in which you perform the design. So that's it from me. Thanks very much for joining this session. You can find me at james@criteria.sh, or you can book a demo with me as well at criteria.sh/contact. Thanks very much.